Hi, Year 10. First of all, huge apologies that I've missed a week last week. I'm likely to miss possibly today's lesson and maybe tomorrow's maximum. I'll definitely be back by Wednesday. That's day 10 for me. So I'm allowed out of my house finally then. So I'm looking forward to getting back. Hopefully, though, you've managed to keep going in my absence. What I'd like to do today is consider the sine and cosine rules together. Now, if you've missed individual lessons on the sine or cosine rule, hopefully this helps. If not, do what you can, and when I come back, I'll hold extra sessions as catch-up sessions for those who feel maybe that they didn't quite pick things up for the lessons I missed. Okay. So today we're going to look at the cosine and sine rules together for non-right angle triangles. Okay. Success criteria, it says, well, we're going to use the cosine rule to find a missing side, the cosine rule to find a missing angle, the sine rule to find a missing side, the sine rule to find a missing angle, and the most important bullet point here is the third in the success criteria. Understand when and where to apply the sine or cosine rule to solve problems. When do I choose to use which one? What are my kind of key triggers that I see in the question that tell me what I'm doing? I do not want you to worry though if by the end of today or tomorrow's lesson you're still not 100% on this, okay? My plan was to finish cosine rule and sine rule by the end of the week, so we've still got lessons when I'll be back in and I can have extra sessions with those who've missed or who just haven't picked it up. So no worries, we're still completely on time where we want to be, okay? And we will make sure that we catch up. Okay, labeling sides and angles. So it says both the sine and cosine rules rely on you being able to consistently label the sides and angles of a triangle. So we should by now know in a non-right angle triangle, the little letter A, B, and C is opposite the big angle. So little a is opposite angle big A, little b is opposite angle big B, and little c opposite angle big C. Okay, as it says, traditionally sides are labelled in a lowercase, A, B, and C, and angles have the uppercase letter A, B, and C. Okay, it does say at the top here, you can think of the cosine rule as similar to Pythagoras' theorem, but adjusted to be used in triangles that aren't right angles. So it looks a bit like Pythagoras, but it's got that extra minus 2bc cos A on the end. Now I'm going to bring my pen in here and hopefully get it to write. But what it's telling us is that to work out A, okay, we will need to know little b, little c, little b, little c, but also big A. So the three things that we'll need to know are this one, and this one. And if you look at them, I think of them almost as a triplet. What they are, they're two sides and the enclosed angle, the angle that is made by those two sides. So B and C come together up here and make angle capital A. So if we ever see that triplet and we're asked to find the other side, then this is the formula we're using, the cosine rule. A squared equals B squared plus C squared minus 2bc cos A. However, an alternative, the cosine rule to find an angle looks like this. Now, we went over while I was actually in how to rearrange this to look like this by moving things around. But for a minute, just learn it off by heart, or I'll have it written down for you so that you can use it, okay? And we'll go over how we rearrange again. But this is to find angle. So to find angle big A, which is this one, I need little b, little c, and little a. Little b, little c, and little a. In other words, to find an angle, we need to know all three of the sides. So if there's an example today where you've given all three sides, you're going to think, okay, I am using the cosine rule to find an angle. And we'll go into the labeling in a second. So let's look at two examples before we get you doing a bit of work. Okay, example one. You can read the top. I'm not going to bother. So I'm looking here, and the giveaway here is side, side, and enclosed angle, the triplet as I call it. Okay, that triplet, and we're using it to find the third side, which is opposite the angle that we know. Okay, so start by labeling your sides. Right, the important thing here is the angle becomes big A, and the side we want to find becomes little a. The other sides then become little b and little c. And sorry that my writing has got away in the way of the letters. Hopefully you can still see them. Again, the note that's come up on the slide, sides B and C can be either way around, but side A must be opposite the angle capital A. Okay, they are the important sides, big A and little a. We get those right, B and C, it doesn't matter. Okay, next, substitute your values into the cosine rule to find the length of side X. So there's the cosine rule, and I'm going to substitute my numbers in. A squared equals B squared, but we know B is 7, plus C squared, but we know C is 9, minus 2 times B times C cos capital A, angle capital A, which is 40 degrees. And we simply put that into our calculator. So I get the answer, sorry, there's a bit of a pause there, that's just me using my calculator. A squared equals, I've put this into my calculator, I get 33.478. And I'm giving quite a few decimal places there because I don't want to lose accuracy in my final answer. Okay, it's 33.478. 3 decimal places seems all right to me. That's A squared. If I want A, I'll need to square root 33.478. And again, I can nip back to my calculator and get the answer 5.8. And this time I am given to 1 decimal place. Okay, so that's applying the cosine rule to find the missing side. And this time the cosine rule to find a missing angle. So as we said earlier, what we'd be looking for here is, well, first of all, it's an angle they want, so that's the biggest giveaway. So it's saying find the size of angle Z in the example there. Give your answer to the nearest degree. Okay, I'll get to that when we get to the end. But the important bit here is noticing we've got the 3 sides. Okay, we've got all 3 sides. We want an angle, we've got all 3 sides, and that's your clues for this one. Again, we'll start by labeling the sides and the unknown angle. Remember though that the unknown angle must become big A, and opposite big A is little a. B and C doesn't matter. Doesn't matter. Either way around, okay? Now, substitute into the cosine rule to find an angle. So we need to just remember this. All right, so it's cos A equals B squared plus C squared minus A squared over 2bc. Not something you need to learn at the moment, okay, it'll be given to you, but something going forward you've either got to learn or you've got to learn how to rearrange the original the original formula to get to that, okay? So cos A equals, and let's put our numbers in, B squared, it's 11 squared, we'll do it like that, plus C squared minus A squared. Notice every time I substitute a number in, it's in brackets, divided by 2 times B times C. Okay, I'm going to come back to you in a second. I'm just putting this into my calculator. Okay, so I get that when I put that into my calculator to be, again, I'm not going to round too much, 0.591 to 3 decimal places. You could even put a couple more, it would be 5909 or to 4 decimal places or so on, okay? But again, there's a little bit more to do, but rather than taking the square root here, it's the cos moving over to find the angle, so it becomes cos minus 1, 0.591. Okay, let me do that again on my calculator. And to the nearest degree, okay, I would have been tempted to put 53.8, but to the nearest degree, I guess that's 54 degrees as they asked in the question. Okay, you can have a go now. Okay, question 1 here is to use the cosine rule to find a side. Question 2, using the cosine rule to find an angle. Get used to what they look like, okay, because when we add in the sine rule later, this will become a bit more difficult. And it says give your answer correct to 1 decimal place. If whoever is taking this lesson, sorry, don't know who that is at the minute, could pause the video now, guys. Have, I don't know, 5 minutes to have a go with these 2. They're on your worksheet. And then when you start the video again, I'll give you the answers and move on to the sine rule. And here are the answers, well, according to me, sat at home doing them anyway. So if I've made a mistake and enough of you tell me I'm wrong and get the same answer, then I'll trust you over me. But very quickly, with my phone as a calculator, I get D to be 8.0 to 1 decimal place. And I get capital A to be 75.6 degrees. If you're a sort of a couple of decimal, couple of decimal places out or whatever, so you're 0.1, 0.2 out, possibly to do with rounding. I rounded to 3, 4 decimal places, can't quite remember. So don't worry if you are, as long as you're in those ballparks, you've done the right thing. And we now move on to the sine rule. Okay, so we can use the sine rule to find a missing angle if we know the length of the opposite side, or a missing side if we know the size of the opposite angle, as long as we know a separate side angle pair. Right, I'll explain that in a second. Okay, so if you want to use the sine rule to find a missing angle first, then the rule we use will be the top rule here. Sine A over A equals sine B over B equals sine C over C. If you want to find a missing side, we're going to put the sides on top. So A over sine A equals B over sine B equals C over sine C. But I call this the opposites rule. Okay, and let me get my pen on here a second. What I mean by that is this. In order to put these numbers in here, I would need to know these two values. Or for the second fraction, these two values. Or for the third fraction, the other two. And the same with the side, okay? But the only way we're able to recognize what a question looks like is to have a go. So again, we're going to unfortunately do a couple of examples. If you want to write them down, do. If not, take them on board, and there'll be plenty of chance for you to try a couple in the next few minutes. So let's start with the sine rule to find a missing side. Okay. Going through my head at the moment, okay, is this. If I knew this side, which I put a little tick on, this side and this angle, then this would be the cosine rule. We would have that triplet. We would have the two sides in the enclosed angle, but we don't. What we've got here is pairs of opposites. This side is opposite this angle, and we know both. And this side is opposite this angle, and we know one of them. So if we look at those two pairs, we know 3 out of the 4, right? And that's the giveaway here. Now I could read all that, but I'm not going to. So the version we need to find the side x, to find a side, is where we put the sides on top. Notice though, I only need to write A over sine A equals B over sine B. I don't need equals C over sine C. I don't need the third pair. Those two pairs are enough to help me here. But for labeling, A becomes the side I want to know. So I know it's x here, but I'm crossing that out. I'm calling it A. Therefore, this angle here becomes big A. And for the other pair, they become little b and big B. Okay, substituting numbers in. Well, we don't know A, but we do know big A. Equals, we know that B is 3. And we know that big B, or capital B, is 52. So I've put in the three numbers. I know, one side, two angles, my apologies, okay? To find A is equal to 3 divided by sine 52. Okay, now A on the left hand side is dividing by sine 43, and the opposite of dividing by sine 43 is to times by sine 43, and that can go into your calculator as it is. I'm going to put it into mine now and come back to you with the answer. And the answer, as you can see, that I get is A equals 2.6 centimeters. Okay, and the sine rule to find a missing angle. Again, you can have a read through that. But I'm going straight into the picture here, ladies and gentlemen. Again, look, I'm looking for cosine rule signs. I don't have those. I've got the two sides, but I don't know the enclosed angle. The other thing that could make it the cosine rule is knowing all three sides, but I don't know all three sides. So then I'm looking, no, this must be the sine rule. This has got to do with opposite pairs. So this is a pair of opposites where I know one of them, apologies, I've got rid of the 1 there, that's 14, and then this is a pair of opposites, where I know both of them. So in those 2 pairs, I know 3 out of 4, but the missing one is an angle. So I am going to put the angles on the top. Okay, so instead of A over sine A, it becomes sine A over A equals sine B over B. For labeling purposes, ladies and gentlemen, you can see the labels have been put on there. The angle I don't know becomes big A, so opposite it little a, and the other angle becomes big B and little b, and we don't need C and C. We're just not going to use them. Okay, so we've got sine A divided by little a, which we know to be 14, equals sine B, which we know to be 20, over little b, which we know to be 5. Much like we did last time, ladies and gentlemen, this side doesn't need to change. It can go into your calculator as it is. But what we're dividing by this side, which is 14, can come over and become a times by 14. So that is what I'm going to put into my calculator, and I'll be back with the answer. So the answer I get, having put that in the calculator, is 0. And I'm going to give it yet again a few more decimal places here because I'm not quite at the end of this. 958 to 3 decimal places. Okay. Anytime we're finding an angle, we've got to be prepared for this final step, be it trigonometry, be it cosine would find an angle, be it sine would find an angle. There's always going to be a final step when we're finding an angle of moving the sine over, or the cos over, or the tan over. In this case, it's sine minus 1. 0.958, and again I'll put that into my calculator, and to 1 decimal place I get 73.3 degrees. Now I'm not going to do examples of those. I'm going to let you jump straight into questions and give you a chance. Okay, so on your worksheet now there are another 7 questions, I think, something like that. Anyway, a mixture, a bit of everything. Okay, so the first 4 on the board. I want you to ignore for a second what you can see in the brackets in question B and D. X is obtuse, X is acute, and so on. If your answer to B happens not to be an obtuse angle, just write down the answer you get. I'll go into what that means because it's probably going a little bit above and beyond, but I will do a lesson on why sometimes the answer we get from the calculator isn't always the correct answer. Okay, trust your calculators today, go with the answers you get, and I'll go into that next lesson. So you've got question 1, and then there's 2, 3, 4, 5, 6, and finally then question 7. So see how far you get with those questions. But to help you, I'm going to ask again whoever's taken this lesson to pause this screen in a second so that you've got these on the board for you. So what we're going to put up is the 4 formulas that you might use. So at the top left, the sine rule to find an angle. Bottom left, the sine rule to find a side. Top right, the cosine rule to find a side. And bottom right, the cosine rule to find an angle. And really quickly, just think about what you'd need, okay? So what would you need for each one? Well, the big giveaway for this one, first of all, is you're looking for that triplet. You'd need to know this with this and this in order to find that. With this one, you'd need to know the 3 sides, and once you've got the 3 sides, you could find any angle you like, okay? So you'd need the 3 sides. With these 2, right, both of them, you're looking for opposites. So you might know this and this, which is a pair of opposites, and then you might know this, but be asked for this, which is another pair of opposites, and the same down here. So you're looking for those opposites, side opposite angle, and you're looking for 2 pairs, but somewhere within those 2 pairs, one of the things won't be known. Okay, pause the screen now and have a go. And the answers.